TypeScript is an open source programming language built on JavaScript that provides static type definitions. It has taken the front-end development community by storm over the past few years, and today we're going to give you a beginner-level rundown on the language. Let's jump right in.
Welcome to the Ladybug Podcast. I'm Kelly.
I'm Sydney.
I'm Allie.
And I'm Emma, and we're debugging the tech industry.
How often have you struggled to learn programming because you just couldn't find the right resource to suit your learning style? I struggled for nearly a year before stumbling upon a website known as Front-End Masters. I've been a long-time paid user of the online learning platform simply because I find the courses to be comprehensive and beginner-friendly. They have the best teachers in the tech industry, and they're one of the reasons I was able to land my dream job. With Front-End Masters, you can learn web development, responsive design, back-end development, animations, testing, algorithms, data structures, and more. You can pick a course you're interested in or follow one of the learning paths like React, Vue, Angular, data visualization with D3, Node.js, and more. To learn more, head to frontendmasters.com.
Transform your business card website into a growth engine with HubSpot's CMS Hub, a developer-friendly content management system backed by HubSpot's full CRM platform. Develop locally with the tools and frameworks you prefer, then deploy to your HubSpot account where marketers can create and edit content using drag and drop interfaces. Designed to scale with your organization, CMS Hub Starter is available for $25 per month. It comes out of the box with fully managed hosting and all of the standard features needed for a fast, secure, and reliable website. Upgrade to CMS Hub Pro or Enterprise for more advanced functionality and develop highly sophisticated user experiences featuring personalization and dynamic content based on natively integrated CRM data. Create a free developer test account at hubspotdev.co/start. Again, that's hubspotdev.co/start.
This conversation, we should start out by just kind of defining what is TypeScript, because some of our listeners might not know. And to be honest, I didn't really know what it was. I thought it was like a framework or a library. But it's actually an open source programming language built on JavaScript. Did y'all know that? Because I thought it was just like a library.
Nope, did not know that.
Allie, did you know that? Because
kind of, yeah. I think so, because it's got a lot of heft behind it. I've been to conference talks by Microsoft on it before, and always found it really fascinating to see. I think I'm at this point with TypeScript where I can like hack my way through it, but I'm not necessarily at the point where I could like write a full TypeScript app from zero.
Yeah, I guess I was always confused that it was a programming language because I use it with React. I've never used it like without React, and so I just presumed that like it was not a language.
Interesting. I used it first with Angular, whatever number Angular is on, or was on like 3 years ago, because that's probably the last time I touched Angular code. And I knew that it was very, very strongly tied to the Angular community in that you pretty much use TypeScript whenever you write Angular code, in my experience. So it's interesting how TypeScript has evolved from using like Flow or whatever for type management within React to more and more people using TypeScript.
Yeah, and it's definitely a love or hate thing. I feel like you don't get people who are like, meh, it's like, I don't really have an opinion. It's very polarizing. But okay, so the quick rundown is it was developed and maintained by Microsoft, and it was first made public in October of 2012.
That was so long ago.
Yeah, it was. And I feel like this is a newer technology, but it's just the fact that like it takes so long to build up notoriety within the community. But TypeScript 4.0 was just released on August 20th of 2020. And just really quickly, and we'll talk about this in a little bit, when we say like strongly typed language, for those of you who don't really know what that means, like JavaScript is not a strongly typed language, which means like data types can kind of be whatever they want. They're more fluid, I guess, right? So if you declare a variable, my name equals string, and you have a value with string, you can reassign that to like a different data type, and it's not bound to one specific thing. Strongly typed languages, you see them primarily more on the back end side. Like Java was what I worked with on the back end, and it was strongly typed. Same with like what other languages are strongly typed, like C, C++,
Yeah.
like
Yeah.
bunch of other ones. Yeah.
I just like the visual of a strongly typed language, just me button mashing on the keyboard, just like really strongly, because that's all I understand about strongly typed.
My favorite is the alternative, which is duck typing. Do you all use the term duck typing for like Python or whatever? Okay, so that's the term for languages without types, because it's like if it walks like a duck, if it talks like a duck, it's a duck. And so with JavaScript or Python, like the variables, you just use them as a string, and because it's a string, you can do certain things with it. And so I like that term. I think it's adorable. I think of little duckies.
That is cute.
That's super cute. I actually love that.
Yeah. So strongly typed basically means like, hey, I've got this variable or this, object with this structure, and it's always going to be this type. You can also, and we'll talk about this in a little bit, where you can have union of types, where you can have it be more than one. You could be like a string or a number, or a string or undefined. But essentially it's saying, hey, I have a piece of data. This is what type it is. And this was kind of really was it really the first like tool or language in the front end side that was strongly typed? I think, as far as I know, it was.
I think there have been other attempts over time, but they've all kind of faded out. I don't know if Flow was considered strongly typed. Did you all use Flow back in the day on top of React? So it was like a Facebook maintained library, I believe, that you could use with React, and it would enforce types. I'm not sure if it would be considered strongly typed or just typed or somewhere in the middle or something along those lines. But it was like a almost more strict version of prop types or something along those lines for React components. But it was just a library. It wasn't a whole TypeScript.
Yeah, TypeScript kind of like prop types was a way to not so strongly type things, because it wouldn't actually throw massive errors. I think it would just give you like a warning if something wasn't the correct type, as far as my experience goes, I think. TypeScript is definitely more robust. But in any case, what's y'all's experience working with TypeScript? Kelly, you said you have literally no experience.
I have no experience. Right? Yeah. I had past employees who were just like, we have to use TypeScript for everything. And I'm like, no, because you're the only one who knows. And then that's kind of polarizing for the rest of the team. And like I will follow tutorials like from Shopify, for example, for like these React apps, and they'll just like throw in a random TypeScript file. I'm like, I don't know what to do with this. So it doesn't work with my code. I'm going to try something else. So yeah, zero experience.
Nice. Allie, you do have experience.
Such light experience with TypeScript. So I have written Angular code in the last couple years that had TypeScript with it, but it was really just like following their tutorials and doing a little bit beyond that and hacking my way through that project. And at work, we use TypeScript for our repos at AWS on the Amplify team, but I don't write production code for it. I sometimes will write like some feature or something as an open source contributor, but it's really, again, just seeing somebody else's TypeScript code, copying it, and then me manipulating it to what I need instead, rather than me starting from scratch and writing it from zero.
I feel like that's the only way that I can do it at this point, because I know enough to be dangerous, and I know enough to figure out. I've been coding for long enough to be able to like see any language and generally understand what's happening to the point where I can make changes and how I need it to work. But I could definitely not write it from zero.
Yeah, I don't think I could either. But so I used some TypeScript in my previous role at LogMeIn, but at Spotify we use mostly TypeScript with React, and it has been an uphill battle trying to learn it, especially on an enterprise level application where we've got these complex types for objects. Like think about, we've got like music tracks, which is an entire playlist. And inside those tracks, we've got track list rows, which have like some of them, if it's a song, it has like an artist and an album and a name and a duration and an album cover. So like we've got all these complex types, and it's really difficult to learn TypeScript while working at that level. So yes, I've learned a lot. One of the common questions is TypeScript a replacement for JavaScript? And I think the answer is it depends. Everyone's favorite response.
The classic response. Yeah.
Yeah. The thing is, it's a strict syntactical superset of JavaScript. So JavaScript syntax is legal TypeScript. But it's a typed superset, which means it adds rules about how different types of values can be used. So for example, if you declare an object that has a width property and a height property, and you try to calculate the area of this object by multiplying object.width with object.height. Let's say you misspell the word height while accessing the height property. If you're using TypeScript, it's going to throw an error and say, hey, this property doesn't exist on this object. Did you mean height? And this can be really, really useful, especially once you start getting into complex data types with multiple pieces of data that you need to access. But one other thing is you can actually develop JavaScript applications client-side and server-side with TypeScript, which is really nice. So I wouldn't say it's a replacement. It's kind of an enhancement for large-scale applications. I wouldn't personally use TypeScript on a small-ass application.
Oh, good. I'm only building small-ass applications. So.
Yeah, like for my mom's personal website or something, I definitely would not be using TypeScript.
Yeah, I would agree. I think it's more helpful as you scale and you have a lot of people working on a project. It makes it so that your code is a little bit more bug-proof. But you also do need a compiler for TypeScript, right? And so setting that up is an additional build process. And so it's not just like you can write a TypeScript file, link it to your index.html file, and well, bam, you have an application. You have to go a little bit further than that. You have to add in like a parcel or something along those lines in order to do that process. And so that's something to think about too if you're building something really, really small.
For sure. Allie, do you know of any advantages of TypeScript?
Yeah, so I think mainly that debugging, like I know that it's so nice within VS Code because VS Code is built on TypeScript. And so a lot of the IntelliSense where you get these pop-ups that tell you more about your own code and you can automatically import things and things like that. A lot of that is enabled through TypeScript. And when you're writing TypeScript code, there's a lot of additional nice features that you have with it, like telling you the types of things and things like that. And so the developer experience is really great. In addition, anything with types is going to be a little bit more resistant to bugs because the types are checked for you. And so those errors will be caught by TypeScript rather than your end user, which is always good.
And I think it's really good to be explicit about how things are meant to work. Because yes, Sally's point does avoid unnecessary errors. But that being said, it also does add a little bit of overhead and additional work up front. So a couple other advantages is that you can use next generation JavaScript features, and these are going to be transpiled for older browsers. You can also use non-JavaScript features like interfaces or generics. So like I had mentioned, like let's say we have an address object, and an address is going to have a street name. It's going to have like a house number, maybe a name associated with whoever's living there. You can create kind of like interfaces for those things that actually create the shape of this object for you. And yeah, like Ali said, like what's really nice is these modern IDEs like VS Code will actually work with your TypeScript interfaces or types to allow you to see what's available on that object. And then we've got, some meta programming features like decorators, which we'll talk about in a little bit. So some of the core types of TypeScript are very similar to that of JavaScript. We've got number like 1, 5.3, -10. We don't have any special integer types like float or double. We've got, the string data type, and we've got Boolean. These are just true or false. There's no truthy or falsy values here. So let's just take an example to illustrate this. Let's say we've got a function called add, and it takes two numbers and it returns their sum. If we call this add function with two numbers, 5 and 2.8, their sum you would expect is 7.8. And this is returned correctly. But let's say that we pass a number, one of them as a string with the value of 5 instead of the actual number version. This would actually return 52.8 because it's using string concatenation. And this is really not what we want, but no error is thrown. So this is where TypeScript can really help you. So in the function signature, we can declare that both number 1 and number 2 arguments are meant to be a type of number. And so anytime a user tries to pass a string, it will avoid this string concatenation error because it's saying, hey, no, we're expecting two numbers, not a string. And so we can do this by typing a colon after the argument name. So it'd be like num1 colon and literally the keyword number. And this then types both of those parameters as a number type. So when we try to pass the first number as a string with our add function, this is now going to throw an error saying this argument of type 5 is not assignable to the parameter of type number. So that was a very simplistic or foundational example that kind of illustrates how we can use TypeScript on a very small scale. Did that make sense, Kelly? How does that from a beginner perspective?
No, that actually makes a lot of sense. And I'm thankful for that explanation, because that's one of the things that I've seen with TypeScript, is seeing like number being declared there. And I was like, why? Like, what's the point of this? And then when I like would put it into my like a .js or .jsx file, whatever, I'd see an error thrown saying this is only to be used for TypeScript. Now it makes sense why.
Absolutely. So those were the core data types in TypeScript. But let's talk about TypeScript types. So let's say we've got an object and it's called person, and it has two key value pairs. We've got name, which is a string, and age, which is a number. If we try to access a key that is not found on this person object, like height, for example, TypeScript is actually going to throw an error for us. So yeah, I think that's really, really useful if you try to like, it's hard sometimes when you're developing these large applications to know exactly what's expected or like what you have access to. And a lot of times it prevents mistakes and helps you debug a lot quicker. So yeah, like we just discussed how you can type core types like numbers and strings, but we can also type objects. So instead of just writing like const person with type of object, we can be more specific about what that object is expecting. So we can actually declare an object literal as the person type and state that this object should have a name property with a type of string and an age property with a type of number. So you'd see like const person equals, and then an open and close curly brackets for an object literal. And then inside, your name colon string, and then age colon number. So that's how you would type out an object. And of course you can save those objects as like a variable. Like you could say like, oh, like person type, and then declare that object literal and set, const person of type person type.
I would love to hear about somebody's experience listening to this episode when they have zero coding experience, because you just said a lot of words that I imagine be like, this is not a sentence. Like, what is happening here?
Yeah. When I say, for those listening, if you don't know what an object literal is, it's where you literally type open and close curly brackets. That's object notation. And inside you add all of the key value pairs.
Yeah. And it's worth noting that we have a couple of beginner JavaScript episodes that could be worthwhile listening to before coming back to this.
Absolutely. We'll link those in the show notes if you would like to take a look at that. Okay, so we've talked about objects. Let's talk about arrays, because these are another type that are very commonly used. So let's stick with our person object example. Let's say that each person has an array of favorite foods, because I know that we all love food so much. So TypeScript can infer that this array is probably an array of strings if you're just passing in like like spaghetti and macaroni and...
Thank you for starting with spaghetti.
Yeah, of course. So to actually say that this is going to be an array of strings, we're going to write the keyword string followed by an empty array, like open and closed, braces, like, the square brackets.
Yeah.
Square brackets, yeah. And so that's how you would actually type an array of like strings, for example. If you wanted a number array, you would type the keyword number followed by the open and closed array brackets. And so that's how you would type an array.
I think that's awesome, because normally you want all the data in your array to be the same data type. You don't want to be dealing with numbers and strings and all that. In that case, you would just use an object most likely. Otherwise, you're going to be looping through this array and doing weird things, and it's not going to be doing what you want. So I think that TypeScript enforcing the type of it is important. And this is what you do with databases too. Like if you have a database and you have an array field, you normally have to say, oh, this is going to be a string that's stored in this array field.
I can't imagine, I can't picture a situation where I would want a mix of strings and integers or numbers in an array.
I mean, you can use the any type within TypeScript too, right? Have we talked about that? Oh, we have that down in the notes. So we'll talk about that.
Spoilers.
Absolutely. So let's talk about some of the more TypeScripty types, like tuples. Tuples? How do you say
tuples,
that?
but that's because my CS 101 professor called them tuples, but I've heard many more people after the fact call them tuples.
I have no idea. I just wait for other people to say and then I copy them.
Let's see what the internet has to say. So according to the Cambridge Dictionary, in the US, it's supposed to be pronounced as tuple.
Okay, so...
as well as the UK, so I'm wrong. So I would say tuple, but yeah, it's tuple.
Okay.
It's okay. We can argue about pronunciation all day. So
sweet. Okay, so you can also use tuples in TypeScript. So, for example, if we have an array called role, let's say it indicates a person's permission status. Let's say you're like an admin for a database or something. So the role array will always contain 2 items. It's going to be a number that indicates the person's permission level and a string containing the label for that permission level. So administrator, for example. This type should be written as an array with a pair of brackets and the keyword number and string separated by a comma. So this is going to tell TypeScript, I want to have a special array with exactly 2 elements where the first element is a number and the second element is a string. I have never used a tuple in my entire life. However, I do know that they exist, and in order to sound smart, I decided to talk about it.
I've used them a ton in other programming languages. So from what I understand, they're really helpful because they're immutable. So if you want to have an array that never changes, you would use a tuple instead. And they're more efficient from a memory perspective for that reason. I don't know about TypeScript tuples exactly, but that's how they are in Python, at least, that they're a lot more efficient because you don't need to optimize for insertion or deletion. They're immutable.
That's super interesting. Yeah. I had no idea. Okay, well, if any of y'all listening know any other use cases for tuples, let us know. Cool. So let's talk about enums now. I like enums a lot. And let's talk about why. So an enum is essentially a set of 3 different values that a variable can contain. So let's go back to our permissions for a second. Let's say our permission level could either be admin, read-only, or author. And admin would be a level of 0, read-only a level 1, and author level 2. So we can actually use this enum keyword followed by a set of curly braces, and inside you're going to define these values. So we could declare 3 global constants that indicate the 3 different roles a person can have. So admin equals 0, read-only equals 1, author equals 2. And then we have to update our role type from a tuple to one of these 3 values because we can either be an admin, read-only, or author. There's no other options for that. And enums are going to make your life so much simpler. So instead of declaring 3 global constants, we can declare an enum called role, for example, that can be one of these 3 values. And now we can just set our role key on the person object to be the enum of role. So inside our person object, set role, colon, and then whatever you called your enum, like person enum. And it'll say, hey, this value is going to be one of those 3 inside of our enum. And this is super great for auto-completion. I love this feature. I try to use enums as much as I can because it's saying like, hey, like you have an exact set of things that this value can be, and that's it. And it'll help you complete it. It'll help prevent errors. Totally
Agreed. They're one of my favorite things in programming, not just TypeScript. So I have an Instagram type clone as one of my demos that I do in conference talks. And one thing that I do is that on an Instagram timeline, you can have different types of content. So it could be images, it could be galleries, it could be videos, right? And so I store that in an enum, whether it's an image or a video or a gallery, and then it makes it so that it's not just a Boolean, not just a number, but it's these set values.
Yeah, I love that. And you'll actually be able to recognize enums based on their casing. So we typically declare enums with title case. So the first letter is going to be capitalized. It's a little bit easier way to identify them than just like the traditional camel case or snake case. You can't use snake case for JavaScript
and then
variables, can you? It's just for CSS.
Yeah, I think so. And then the values themselves are like screaming snake case. So they're all...
Oh, kebab case.
Screaming.
Holy hell.
Screaming
I can't
snake
even.
Case. So they're all uppercase and underscores.
Screaming. Beautiful. Oh, God. Anyway, there's one more type I want to chat about, and this is called any. So any kind of value you can literally have any type of value. So let's say you've got like an unknown variable. I don't know what you would call this, like birthday. Let's say a person has a birthday and you don't know what type of structure this is going to be, whether it's a date, a number, a string, etc. You could theoretically set this to type of any. It's just lowercase any. It has no specific assignment. However, this is not great practice because it actually defeats the purpose of a strongly typed language. I was joking about like how I was just setting all of my types to any when I was starting out. I actually still do use any if I'm like developing and I just don't have the time to go fill in a specific like complex type at the moment. I just need it to like compile and I'll come back to it at a later time. But yeah, you really shouldn't be using any in production.
Out of curiosity, do people write tests to check for any being used? To be like, hey, you used any 4 times. You want to change that?
I'm sure there probably is a
Yeah.
tool because it's the internet.
I think
But I feel like there's probably a linter option or something.
That's what I'm wondering. Yeah.
there's like TSLint, which is like ESLint for TypeScript. And I'm pretty sure that's one of the things that it catches is too many any's. Or at least it like warns you about it.
Too many any's.
No, indeed. Well, I know this was a lot. It's only going to get harder in the next upcoming sections. Kelly, how are you feeling so far about TypeScript?
I have no idea what I'm doing.
But hopefully what we said just makes sense.
It makes sense, but I would need time to actually like see it in
Digest it.
action
Yeah.
instead of like listening.
Yeah.
Exactly. Yeah.
That's true. It's also really hard to like listen to a podcast talking about this. But when we come back, we're going to hear from our sponsors. But when we come back, we're going to dive into some more confusing concepts.
Oh, good.
We often hear from listeners who are looking for a new job. And we've got a pretty cool opportunity today for anyone who's interested in joining a fast-growing startup. The company is called Geneva, and they're hiring iOS, Android, front-end, and back-end engineers. So, what is Geneva? Geneva is a startup that's building a new group communications app that makes it really easy for people to chat, to hang out, and to stay connected with all of the groups, clubs, and communities in their lives. In a world where everyone is on social media, either yelling at each other or showing off, Geneva gives groups a safer, more private space to have a genuine conversation, make new friends, and build more meaningful relationships. You can think about it as a more modern-day, privacy-focused replacement to Facebook groups, or like what Slack would be if it was designed for social groups instead of workplaces. After about 2 years of building and growing, they now have the backing of some of the top investors in the world, including the co-founders of Reddit, Instagram, and Patreon, and are looking to ramp things up to move even faster. The team is about 42 people, with half based in New York City, and the other half working remotely across the world. So, if you are an iOS, Android, web, or backend engineer and interested in helping to shape the future of how we all interact and socialize online, check it out. You can learn more at geneva.com. This episode is brought to you by Dexecure, a company that helps web developers save time by automating repetitive optimization tasks. Images, JavaScript, CSS, HTML, fonts, and even third-party assets. Dexecure optimizes them all with just one line of code so you can focus on what you love doing, building new and exciting websites. No matter the device or browser type, Dexecure will always deliver the best version of your website. Visit dexecure.com/ladybug or enter the code LADYBUG for 1 month free when you sign up for any basic or pro plan. Or try it out with a free account.
Cool. So before the break, we talked about some of the core data types within TypeScript, and now we're going to talk about some of the cooler, more complicated types. Let's talk about union types. Are either of you aware what a union is in programming?
Like with if you
No.
For example, if you have 2 sets, you can see the overlap of those sets with the union. So if you have one that's red, green, and blue, and then the other one that's green, blue, pink, the union of those 2 would be the green and blue because it's in both sets.
Nice. We're not talking about unions like you're going on strike, Kelly, but nice try.
That'd be fun.
Yeah.
It's an important topic to discuss.
Going on strike from Ladybug right now. I'll be in the other room.
You're fired. Cool. So let's go back to our add function. Remember, it took in 2 numbers and returned their sum. So let's make this a little bit more extensible. Let's call it combine. So instead of just adding 2 numbers, it's going to accept 2 different arguments and just return their combination. So if we pass in 2 numbers, you would expect it to return their sum. But if you pass in two strings, you would expect it to return their concatenation. And so we need to tell TypeScript that these arguments could be either a number or a string. And to do this, we can declare the type as a number or string, where the or is actually the piping symbol. So like the straight line that you would use for like Boolean ors. You're just one of them. So number or string. Yeah. And that's how you declare a union type. It's not too complicated. It can get complicated the more unions you have, but I think in terms of like this combine function, I think that makes a little bit of sense.
For sure.
That makes sense to me.
Sweet. Okay. Now let's talk about literal types. So let's say we've got an object called t-shirt, and it has a property, color, which accepts a string value. And the shirts can only be blue, purple, or red. We could actually declare these string literals in TypeScript. So we create a t-shirt object, so const t-shirt equals, object literal or open and close curly brackets. And inside these curly brackets, we are going to set type of color to the union of these three string values, blue, purple, and red. And remember that union we just mentioned is the piping symbol or an or symbol for Boolean. So it literally would read like const t-shirt equals open and close curly brackets. And inside you would have color, colon, and then you've got your three values. So blue in strings, or purple in strings, or red in strings. And so now we know our t-shirt can only have a color of one of those three values. It makes a lot more sense to read it. And so if you're listening and you're having trouble visualizing it, maybe just try to write it down if you're able to, or go take a look at some TypeScript docs like on their website. It might help visualize this a little bit.
Okay,
better.
I have a question for you, and you can say that this question doesn't make sense or whatever. But how do you decide whether to use a union type or a literal type versus an enum?
That's a good question. I think they kind of can be both. Like you could, I think, do, either or. I don't know for a fact. And if you're listening and you know the answer, tell us. I don't know, because I've seen both in our code at Spotify. I think enums are maybe meant for more complex data types.
Yeah, maybe if they're reused. That would be my guess.
Yeah. Oh, that could be too. Yeah. It's more extensible
cool.
that way.
Cool. I'm glad this wasn't just me thinking about it.
That's a really good question. I don't know. From appearances, it seems you can do similar things with both.
Okay. Just wanted to check.
Yeah, no, that's a great question. And again, if you're listening and you tell us because we want to learn. Let's talk about aliases. So I think we have the concept of aliasing in many different concepts in programming. I know like for React, you can alias incoming arguments as, a different name, or if you import something, you can import it as something else. And I think that concept is aliasing. This concept also trickles down into TypeScript. So when working with union types like number or string, it can be a little bit redundant to declare this union type over and over. You don't want to have to type it out a bunch of times if you're reusing it everywhere. So we can create aliases to store this union type. And honestly, an alias in this instance is kind of just like a variable that holds those two types. So you can alias types using the type keyword. So this type is usually title cased, so the first letter is capitalized. Let's go back to our combine function. Remember, it accepts two arguments, either a number or string type, and it returns their combination. So we can create a new alias by declaring type, followed by the name of whatever type you want to call it. Let's call it my value. Remember, that's title cased. So my and value are both capitalized. So type my value and then equals number or string. Those two keywords separated by that piping symbol for union. So instead of typing number or string for both arguments in the signature of the function, you can just set the value equal to my value, which we've just declared as an alias. So it's a little bit more extensible, a little bit nicer to read if you're reusing it all over the place. Although honestly, like if I wasn't reusing it everywhere, I probably wouldn't do it. It's just kind of like abstracting things unnecessarily sometimes. But it does help if you're building a large application with many, many different union types. Let's talk about functions, because typing functions can be a little bit tricky. Right now, we've just kind of talked about foundational data types, but what about function types? Let's return to one of our earlier examples, which let's go back to the add function. So it's no longer a combined function. We're back to the add function. It takes two numbers and returns their sum. So each argument is of type number. But what are we actually returning from the function? So since we're summing two numbers, our return type is also going to be a number in this instance. And we can note a function's return type by adding a colon, or the two dots, after the closing parentheses of the function signature. And then you just add whatever the return type is. So if I were to read our add function signature, it'd be function add. And in our parentheses for our arguments, it would be num1 colon number. This is of type number. Num2 colon number, again, type number. And after our closing argument parentheses, we also have a colon number, followed by our, curly brackets with the function body. So this is just saying, hey, this function takes two arguments. They're both of type number, and it will also return a number. However, sometimes we have functions that don't return anything. What do we return in this instance? Allie, like if you have a function whose job is to perform a side effect, like making an API request and nothing is returned, do you happen to know like what the function return type is?
Yeah, it's usually like undefined it's usually undefined, right? In JavaScript?
I think it's void.
But in normal JavaScript?
Oh, in normal JavaScript, I have no idea.
Yeah, it's undefined, I believe, in normal JavaScript. So then I think
you're right, yeah.
With...
What is this, a technical interview?
Like,
now?
Oh no, that's putting me on the spot. No.
I'm like, Allie, it's in the outline. I just don't want to talk.
No, you're good. You're good. I was like half paying attention here. Okay, cool. So then with TypeScript, it would be void. And that makes sense because that's kind of a cross-language thing. You have like void methods or whatever if it doesn't return anything.
It's also not uncommon to pass functions around as arguments. Here's another technical interview question. Kelly, do you know what that's called? When you pass a function as an argument?
Pick me.
Allie, phone a friend.
Higher order functions or callbacks, depending on the case.
Yeah, for sure. So today you learned higher order functions. So if you want to note that a variable actually contains a function, we can note this with the function keyword. So it's capitalized function as a keyword, and it tells TypeScript that this variable contains a function. So let's say we're passing our add function as a callback to a different function. Let's say this function expects an argument called callback and it contains a callback function. So when we're passing our add function as a callback, it's still going to contain the same signature as it did previously. So we're going to have num1 colon number, num2 colon number, and after the parentheses, it'll still say, hey, this function is going to return a number. We're just going to assign this entire function signature as the type for our callback variable that we're expecting. It's a little bit tricky. And again, I highly recommend go looking up how to type these types of things. Typing functions as variables is a little bit tricky. But once you see it, it'll be a little bit clearer, I think. So essentially in English, what this is saying is to our higher order function, hey, we're expecting a callback function parameter to be passed. This callback is going to take in two arguments of type number, and it's going to return a number. That's all it's saying in English. And once you see it written down, it'll be a little bit less difficult to picture. But unfortunately, we are in podcast. So this is your homework if you're listening. That was a lot. But I will say that was the most difficult concept of this episode. So if you are still with us and you have not exited the podcast, I commend you because I would.
And if you're still with us and you're also confused, know that you're in good company.
Absolutely. But okay, listen, we talked about this any type earlier, and I'm here to say that there is actually a type that we can use in lieu of any. If you simply do not know, and I'm not going to say simply because I hate using that word. If you do not know what type of data you are expecting, there's actually a type unknown, and this is better than using any. It's just going to indicate that we're unsure what type this value is going to be. So for example, if we're relying on user input, we don't know what type of data they're going to enter. So I recommend using unknown in place of any. Yeah, and that was a lot. But that was essentially the foundations of TypeScript and the types that you can use. How are you feeling, Kelly? Do you feel like you want to jump off a cliff?
Yeah.
Oh, no.
Sweet.
I'm really excited to go to Front End Masters and put my membership to use.
Yeah, they have a few courses with TypeScript, and I really love them. I think the teacher's done a really great job. There's a TypeScript 3 Fundamentals course by Mike North. But there's also a React and TypeScript course by Steve Kinney if you're working with React as well as TypeScript. And my shout out for the week because we can transition into shoutouts. My shoutout is actually for a book that was released called TypeScript in 50 Lessons. It's by Stefan Baumgartner. It was released through Smashing Magazine, who we love. And it's just that. It's TypeScript in 50 Lessons. And it's very visual. It's a beautifully made book. So if you're more of like, I don't know, not a visual learner, like if you like to read to learn, highly recommend checking out that book. But it seems like there are a couple of other books that y'all are recommending, huh?
There's a theme to these shoutouts.
There is a theme to these shoutouts. Kelly, what's your shoutout?
So I want to shout out People We Meet on Vacations by Emily Henry. If you read Beach Read last year, which was like super popular summer pandemic read, same author. She came out with this book. It was released, I think, about last month. Really, really cute, really great read. Highly recommend.
That sounds good. I've been looking for like beach reads because I've been reading a lot of like heavy hitting books.
Yeah, I'm back on my trashy romance kick. This is not trashy romance.
I don't know. I always like to have one of those going. The romance. Yeah.
I need it.
The cute. Yeah.
Yeah. It's very formulaic. I know exactly what's going to happen. I know when I'm approaching a certain percentage on my Kindle, something's going to happen. And then we're going to recover from it. It's great.
Yeah. And then there's the second twist close to the end that you get all emotionally caught up again, and then it's resolved. Yeah. 100%.
Exactly.
It's like a formula. Mine is also a book. What else is new? I think that we should just go back to making these shoutouts really just a book club. But mine is Crying in H Mart, which is a really great book. I think it's really popular this year, but definitely a heavier read about a woman's identity and also tied up in her mother and her mother having terminal cancer and just tying all these stories together. So I think it's really good.
Oh my goodness. Okay. Well, if People Meet on Vacation was too easy of a read for you and you don't feel like reading TypeScript in 50 Lessons, go check out Crying.
Maybe the three of these.
We just gave you three different
pairing
books.
The three of these would be good. So you're learning things, you're brought into
emotionally invested.
And you get to recover.
And you get a break.
Fabulous. Well, if y'all like this episode, tweet about it. We always select winners to win things because that's what winners do. We are going to select one tweeter to win a copy of Stefan Baumgartner's book, TypeScript in 50 Lessons by Smashing Magazine. So be sure to tweet and we'll pick a winner. We post a new podcast every Monday, so make sure that you are subscribed to be notified and leave us a review. And with that, I hope y'all have a great day.